Welcome to Engineering Funda family. This video is a part of Microcontroller 8051 video lecture series, and in this video I will be going to explain you few very interesting and important terminologies of Microcontroller 8051. Like I'll explain you how ALU is functioning with 8051, like what is the significance of accumulator resistor B, as well as PC, stack pointer and PSW resistor that is there with 8051. So I'll explain you each and everything with examples, so that will gives you more clarity. Let us see all those things step by step. So first of all, I'll explain you how ALU is there. So arithmetic and logic unit, that is a part of CPU that you should know. Here with 8051, we have 8 bits of ALU that is responsible for execution of instruction along with arithmetic and logical operation. So all the arithmetic and logical operation performed inside CPU is been done by ALU. Size of ALU is 8 bits with 8051. Here my dear students, it is not only 8 bits of arithmetic and logical operation that can be there with ALU. Here you can perform single bit operation as well. Let me give you some examples so that will give you more clarity. For example, when you execute add a comma r1, all you do is you will be adding accumulator A with r1 and result will get stored inside A. You should know my dear students, A, r0 to r7, all the resistors are having size of 8 bits. So here we have performed 8 bits of addition. When you execute CPL P0.3, what you do is you will be complementing this bit of port 0. Port 0 is having 8 bits. See, here we have port 0. So this port 0 that is having 8 bits. In that P0.3, that is 1 bit of that port that we can complement by this instruction. So this ALU can perform 1 bit operation as well. So in short my dear students, you should know 8051 performs 8 bits of arithmetic and logical operation, as well as it can perform 1 bit logical and arithmetic operations. Let me explain you second term, that is accumulator A. Accumulator A, that is a resistor with size of 8 bits. Here my dear students, you should know this is special resistor. Why? The reason is most of the arithmetic and logical operations of 8051 that happens with respect to accumulator only, right? So here accumulator is used with most of the arithmetic and logical operations. Here if I give you some example, then it will give you more clarity. Like when you write add a comma r0, what you do? You will be adding a with r0 and answer will get stored inside a. As if you execute a and l, what you do is you perform logic and operation. When you write a and l, then a comma r1, then you will be performing logic and operation of A with R1 and then you will be storing answer inside A. So almost all the arithmetic and logical operation that can be executed along with resistor, which is accumulator A. Now my dear students, I'll explain you one more essential resistor, which is resistor B. It is also having size of 8 bits and this is dedicatedly provided with 8051 for multiplication and division instructions. Let me give you example. Like when you write MUL AB, what you do? You multiply A and B and then answer will get stored inside BA. You see, when you have two data multiplication, that data is having size of 8 bits only. Accumulator is having size of 8 bit. This B is having size of 8 bit. When you multiply 8 bit into 8 bit, your answer will be of 16 bits. So 16 bits that will get stored inside again BA, where B will hold higher byte and A will hold lower byte. That is how it is getting stored inside BA. So B is dedicatedly provided for multiplication and division. When you write div AB, what you do? You will be doing A divided by B operation. Now here when you perform this, your answer will be there in terms of quotient and remainder. So quotient will be there inside A after A divided by B and remainder will be there inside B after A divided by B. That is how A and B resistors are there inside 8051. Now my dear students, I'll explain you how program counter is there. So you should know my dear students, 8051 that is based on Howard architecture. Howard architecture means what? Howard architecture means for program and for data we will be having separate memory. You see here internally we have 4 KB of ROM and 128 byte of RAM. So RAM will be holding data and ROM will be holding program, means instructions. So address of instruction inside program will be pointed by PC. So whenever you execute any program, you will be executing that with respect to one by one instructions. So that instruction address that will be pointed by PC. It is having size of 16 bits and you will be observing instruction address that will be there with PC. So when you fetch one instruction, automatically PC will get increment and it will be pointing next instruction to be executed. So for example, here you are writing program. Let us say first instruction that is getting fetched. PC will get automatically incremented by 1. It will be now pointing next instruction. Once first instruction is getting executed, PC is already having next instruction's address. So now next instruction is ready to be fetched. Once next instruction is getting fetched, PC again will get automatically get incremented and it will be pointing third instruction and it will wait till second instruction is getting executed. So what will happen is, my dear students, PC increments automatically once you fetch any instruction, and those instructions will be there in program memory, means it will be there inside ROM only, as 8051 is there based on Howard architecture. Now my dear students, I'll explain you DPTR, data pointer. Data pointer DPTR, that is having size of 16 bits, right? And my dear students, it will be holding address of data in data memory. Data memory will be RAM always. With 8051, it is there with Howard architecture. Program memory will be ROM, data memory will be RAM, program memory will be pointed by PC, data memory will be pointed by DPTR. That is how it will be there, you should know that. So here DPTR, that is holding data of RAM memory, right? So here you will be observing it is further divided into two parts. DPTR means DPH means higher byte of DPTR and DPL means lower byte of DPTR. Here my dear students, this DPTR that is of 16 bits. What it means? It is not pointing internal RAM. You see internal RAM is having size of 128 bit. So address of internal RAM that is just of 8 bits. But here how much size is there with DPTR? 16 bits. So obviously this DPTR that will be pointing external RAM. As if you interface external RAM, then only that data will be pointed by DPTR. Remember this. It can also be used as a pointer for lookup table. Like you see what I have told you is, you will be using ROM for which purpose? Program. Program will be having what? Instructions. And you will be using RAM for which purpose? Data. Right. Why we store data inside RAM? The reason is data may be volatile. But in some cases, as if you wanted to have data that should not be volatile, in that case what you will be doing? Obviously, if data is not volatile, in that case we must store inside ROM. When you store those data which are not volatile inside ROM, at that time you will have to make lookup table and you will have to store it inside ROM. And to access that, you can use this DPTR. So here what you can do is, you can make index addressing mode by which we can have usage of DPTR. Let me explain you by example. Here when you have lookup table operation, at that time remember you will have to write move x. Do not forget this x, right? When you write x, what you do is, you will be using DPTR as per pointer, right? See, normally what we write is move a comma any address, right? So at that time it will be taking data inside A, that is normal move. But when you use this DPTR as a pointer for RAM, at that time you will have to write x over here. So what will happen? You see, when you write move x a comma @ DPTR, means RAM is pointed by DPTR and at that address whatever data is there, that you will be moving inside A. Now you see, I'll give you one example which is there based on lookup table. When you want to access lookup table inside ROM, at that time you will have to use C. After move, you will have to write C. When you write move C A comma at the rate A plus DPTR, then all you do is here A plus DPTR, that will be my address, that is the address of ROM, and at that address whatever data is there, that I will be moving inside accumulator A. That is how this move C is operating. So move C is there in terms of index addressing, right? So that is how DPTR is working. Now my dear students, I will be going to explain you stack pointer. Stack pointer is having size of 8 bits and it will be holding address of top of stack. You should know my dear students, this stack that is operating as per last in first out, and address of that stack will be holded by these 8 bits of register which is there with stack pointer. And you should know my dear students, you see here we have internal RAM of 8051. So this internal RAM's address, that will be holded by stack pointer. So internal RAM is having stack memory only and address of that will be there with SP. You see 128 byte of internal RAM is there. So 128 byte means what will be the address range? It will be starting from 00 hex and it will go up to 7F hex. So that internal RAM will be working with stack memory and that memory will be pointed by stack pointer register, right? So internal RAM address that is ranging from 00 hex to 7F hex and that is having stack memory area that is pointed by stack pointer register. We use that with push and pop instructions as well as we use stack memory in subroutine as well as interrupt subroutine. So this stack memory which will be used for subroutine as well as interrupt subroutine, when you reset this 8051, at that time this stack pointer will indicate 07 hex address of internal RAM, right? Why? The reason is this internal RAM is also holding registers data, right? So on reset, it will be having initial address of 07 with SP. Here my dear students, there are many other things which is happening inside this RAM, but here you just understand this internal RAM will be having stack memory that will be pointed by stack pointer that is having size of 8 bits. It will be having range from 00 hex to 7F hex. In future coming videos, I will explain you how this internal RAM structure is there, that will gives you more clarity. Here my dear students, when we talk about PSW, then you should know it is program status word. It is of 8 bits and it will be showing you status like whether carry is there or not, like whether overflow is there or not, right? So that is how status is indicated by PSW register and that operation will be performed inside CPU. So whatever operation that we performed by executing instruction, after every instruction execution, this PSW flag will change. How it will change? For that, I'll make separate video. In that, I'll show you how all the flags are there. Here, just understand one thing. PSW is having size of 8 bits. It is holding status of program and it will change after every instruction execution. And we can also change the status of flag by executing instructions like set B PSW 0.2, clear PSW 0.2. So here we are setting this bit, we are clearing this bit. Why? The reason is PSW is bit addressable register. So here bit by bit operation can be performed as well as you can have complete register operations, and this flag register is showing you how program status is there. So in next coming videos, I'll explain you how PSW is there. So I think now you are having fair enough idea about how all these elements are there with 8051. Still, if any confusion is there, just post that in comment box. I'll be happy to help you. Thank you so much for watching this video.